Let's kick this off. Thank you, everybody, for choosing this session titled "Harnessing the Evolution of Earth Observations and Risk." I'm quite confident that you've made the best decision possible by attending our session today. We have some really wonderful speakers, and I do thank our speakers for their time and efforts in contributing to this session and sharing with you, the Understanding Risk Forum 2020 community, some recent updates from both our GEO and CEOS communities. My job today is to give a very brief background and lay a bit of a foundation for those that might not have much or any understanding or background in terms of GEO or CEOS, and then to quickly hand it off to our wonderful presenters for their engaging presentations. So with that, GEO and CEOS, as the abstract indicates, what are they? Group on Earth Observations is an international partnership of more than 100 participating organizations and more than 100 as well national governments. And we work collectively towards a future that we envision where decisions and actions for the benefit of humankind are informed by sustained, comprehensive, and coordinated Earth observations that allow for evidence-based decision-making, among other things. GEO, Group on Earth Observations, does at this time have three primary engagement priorities that guide most all of the activities that we undertake within the GEO community. And those do include the United Nations Sustainable Development Goals, the Paris Climate Accord and Agreement, and of course the United Nations Office for Disaster Risk Reduction, UNDRR Sendai Framework for Disaster Risk Reduction 2015 to 2030, which obviously I think is the engagement priority of note for today's session. GEO has quite a comprehensive work program, which currently is in its 2020 through 2022 iteration. Right now, I tried to imagine a more interesting way to show our work program, but really I think that this graphic, while not intended to be able to read anything, I think shows the broad coverage of all of the efforts across the GEO community. There are more than 60 work efforts underway. They span a very broad field of different thematic focuses as well as regional focuses. You can see that the Africa, the Americas, Asia, Oceania, and Europe all have regional groups on Earth observations that work in those particular geographies towards a variety of different community activities, initiatives, and flagships, many of which perhaps as much as half of this work plan have relevant disaster risk reduction efforts underway within them. So distinct from Group on Earth Observations, but a participating organization and strong contributor to GEO is the Committee on Earth Observation Satellites. And while GEO is very inclusive and holistic in terms of incorporating all types of Earth observations, so those that might be space-based as well as in situ or in situations, things along the lines of stream gauges and other such in situ Earth observations, CEOS is particularly focused on space-based Earth observations and is considered widely across GEO as the authority on space-based Earth observations. And it does ensure coordination of more than 30 civil space-based Earth observation programs at a national level around the world. And one of the primary focuses within CEOS is our working group on disasters that does ensure sustained coordination of disaster-related activities undertaken by all CEOS national space agencies. And we act as that interface between CEOS and the broad community of disaster risk reduction stakeholders. Both within GEO and within our CEOS working group disasters, we do have a variety of different global policy alignments to include the UNDRR Sendai framework, which will be discussed in more detail in the coming presentations, as well as things such as the United Nations Global Geospatial Information Management, which has a working group on disasters, and in the past year or so has published a strategic framework on geospatial information and services for disasters. Within our working group, CEOS working group on disasters, we also have quite a broad range of work plan activities to include some of the topics included on this slide, such as volcanoes, geohazards, wildfires, landslides, and all in the context of integrating the hazards with the exposure and the vulnerability towards disaster risk reduction goals. So with that, I will stop talking and I will hand it over to our first presenter of this session, Ms. Janet Edwards. Janet, please go ahead. Let me stop sharing. Thank you so much.
Okay, thank you very much, David. Earth observations data can help solve problems. We've been using it for urban planning and agriculture, forestry, resource management. We're also using it for sustainable development, risk identification, and climate change adaptation. And all this adds up to building more resilient societies. The idea with the working group that we're now going to discuss is to make a link between the Earth observation specialists and scientists and the disaster risk reduction professionals, and together to find activities that will help us to fulfill the work program for GEO. The name of the group is the GEO DRR Working Group, and it will provide Earth observation information that's useful for all phases of disaster risk reduction. Also information for national and local disaster risk reduction strategies, and for climate change adaptation and sustainable development. The first subgroup of 3 subgroups will coordinate DRR-related activities across the GEO work program. They will improve ability to reduce disaster risk, and they will also provide a GEO toolkit or more for DRR. There will be information about Earth observation for Sendai framework policy making and also for actions. Subgroup 2 is working in connection with the United Nations Disaster Risk Reduction Office, and they have helped us find our focus. And the focus will be on national and local disaster risk reduction strategies. And by doing this, we will be fulfilling one of the Sendai framework's global targets, which is Global Target E. While doing these national and local priorities and national and local disaster risk reduction strategies, we're looking at priority 1, understanding disaster risk. And of course, Earth observations will give us a whole portfolio of information that we didn't have before. Priority 2, strengthening disaster risk governance to manage disaster risk. And here, policy development, which we will be working on, is very important. And priority 3, investing in disaster risk reduction for resilience. And of course, we want to invest in the technology for Earth observations data. And the 4th priority, also a challenge, is not only disaster preparedness, but also to build back better after an emergency. Another thing that subgroup 2 will be working on is visualizing exposure and vulnerability. In this slide, you see that there's enough data that you can get a good information about not only risk hazard flood, but also what the consequences would be. In this photograph, you'll see the landslide hazard. Also important with satellite data is that you'll be able to see what kind of consequences and predict the level of those consequences. Another thing that subgroup 2 will be working on is identification of future risk trends. Here in this photograph, you'll see that the orange and the yellow show the drought affected areas, and it's quite logical in Southern Europe. However, did you know that there is also a future trend towards droughts in Scandinavia? As David mentioned, there are 3 United Nations agreements here that we're working on, the Sendai Framework and the Paris Agreement and Agenda 2030. And so subgroup 3 has a very important role here because they're working across the GEO work program and integrating and working with the climate change working group. And they're also going to be working with sustainable development. And in closing, I'd like to say that there are lots of risks and there are multiple risks. Our societies are becoming more complicated, and therefore we do need GEO Earth observations to help us to make a safer and more secure society. And in our group, there are 70 members, so they're quite a spread of competence, and we'll be looking forward to their activities that will roll out next year, in the beginning of the year. Thank you.
Thank you so much, Janet. Very much appreciate that presentation. Our next presenter up is Mr. Ricardo Cuerga of the NASA Disasters Program, here to give a brief overview on one of the regional activities, the AmeriGeo Disasters Working Group. Ricardo, please go ahead.
Okay, good morning. Thank you. Let me share my screen. 1 second. Okay, do you have my screen?
We see it, Ricardo, but if you could put it in there, there we go, perfect.
Thank you. Okay, I'm working as a co-chair of the AmeriGeo Disaster Working Group. We are trying to support the same time frame in different priorities. I think that the first priority is engage the community. Community in the Americas is very active because we have a high vulnerable countries in the Americas. We have Central America with the hurricane season. The last season was one big example of how the vulnerable communities are in this region. That's why we are trying to engage in different ways. We are working with embassies, with countries, with disaster agencies, trying to make connections because disaster has no borders. This disaster working group AmeriGeo has around 5 years now, and we have a lot of progress. We have now 20 countries in this region working together. And also we are trying to get together, and AmeriGeo signed, this is a joint declaration with UNGA Americas to trying to working together because we detect a lot of duplication in the region. We have a Aguascalientes declaration that was last September, and now we are in the new start doing many things together. Also, we are trying to engage with different organizations at regional level. UNDRR and CEPREDENAC, which is the regional agency for disasters management in Central America, for the Central American Integration System. Universities in Latin America working for disaster reduction also are part of this group. The different space agencies we are working with, as a Paraguayan Space Agency, Bolivian, Brazil, Peruvian, we have different engagement now. We are starting together collaborations to support this Sendai framework. Also, we are doing webinars, but not as a capacity building. We call ones a scientific exchange and exchange of expertise in different topics. Also, we are working with the new generations, the youth people, doing many things, trying to involve the young groups into this discussion of disaster reduction. We have, for example, the Mapathons, when we bring together the community with the software community, government community, and also academic community with young people involving in these multi-hazard assessments and these kind of studies that many communities are working on. The main concept is how can we download the geospatial data to local communities. Also, we participated in Understanding Risk in Costa Rica with more than 500 participants. That was in February. And after that, we follow up with many actions on this. Also, we are trying to link the geospatial data with regional platforms, as SICA has one. And this platform is also informing at local level. We have a good example with the last hurricanes Iota and Eta in Central America this month. Also, we are trying to engage with GEO projects as GSNL, super sites for geological hazards. And now we are expecting Nicaragua has the first GEO super site in Central America. Also, GEOIS with Wild Information System is getting a new fire historical data for countries. This is really useful, and we expect the launch next week, I think. But countries as Paraguay and Colombia started to using this information to report in Sendai and also in climate change reports. Also important is to understand the risk. We are developing and promoting multi-hazards assessment for cities as a Guatemala City with 1.8 million people in risk. And we need to know in high resolution mapping this kind of vulnerabilities, exposure and vulnerabilities of the communities. This is mapping in 1 in 5,000 scale. We are downloading the geospatial information. And also AmeriGeo's platform is integrating 34 countries in information available online with Esri software for the whole communities. This is open and free for communities to start mapping at the local level. I'm going to leave it like that because of the time, but thank you very much for the opportunity.
Thank you so much, Ricardo. Very much appreciate that. Our next speaker of this session is Ms. Leila Kuhl of Germany's BBK to give us a latest update on a GEO work program called the Earth Observations for Sendai Framework Monitoring.
So thank you, David, and hello, everybody. As David said, I would like to introduce to you our GEO community activity, Earth Observation and Copernicus in support of the Sendai Framework Monitoring, or short EO for Sendai Monitoring. As most of us know, the Sendai Framework for Disaster Risk Reduction was established in 2015 with the goal to reduce disaster risk and losses in lives, livelihoods, and assets. But how do we know that we are on the right track of this, to achieving this goal? So the Sendai framework comes along with 7 global targets and 38 indicators to monitor the progress of implementation. However, the monitoring is not as easy as we might think. Although UNDRR provides methods for every indicator to derive, there's a significant gap in data availability along all countries. In Germany, for example, we currently do not have any systematic methods or established official mechanisms on how to monitor the global targets of the Sendai framework. And this is where we believe that the Earth observation technology can come in. Earth observation can provide, first of all, objective and area-wide information with a high degree of spatial detail. And with the European Copernicus program and, for example, the Landsat archives, Earth observation provides open and cost-free data and data products for everyone to use. But how can we use this advantages of Earth observation for the Sendai Framework Monitoring specifically? First and foremost, Earth observation can be used to create crisis information by mapping an actual disaster and the impact of a disaster on affected objects or population. We can also use Earth observation to estimate population or to identify affected built-up areas or for the assessment of economic assets. And if we put all of these information together, such as the crisis information and other geostatistical data, it is possible to derive a Sendai indicator. And so we believe that Earth observation is a great data source for the Sendai framework monitoring. However, the progress in the Sendai monitor is by the countries is generally very slow, and Earth observation is not used in the monitoring. So we asked ourselves, what is missing for the national focal points of the Sendai framework to build such lost databases, and what do they need to integrate Earth observation in the Sendai framework monitoring. And we at BBK are also have the national focal point of the Sendai framework here in Germany, and with these colleagues we identified, in close cooperation with the colleagues, we identified 2 issues that focal points face when integrating Earth observation. First of all, there's a lack of information and guidance on the possibilities of Earth observation for monitoring disasters, and especially impacts by an actual disaster. And the national focal points miss tangible use cases and specific tools to derive a specific Sendai indicator, because most of the time there's no time or money to develop such things. So we, as the EO for Sendai monitoring activity, what do we want to do as a EO for Sendai monitoring? What do we want to achieve? Together with the community, we want to focus on these end user needs and promote the use of Earth observation by creating a good practice guidance on how to use Earth observation for monitoring disaster impact, and by developing standards and a pilot tool that showcases the use of Earth observation and other geodata to derive probably a Sendai indicator based on economic damages by floods. So we believe that we, with our EO for Sendai monitoring activity, are able to support the Sendai framework monitoring, especially for the Sendai framework targets B, C, and D, which is the reduction of affected people, economic losses, or damage to critical infrastructure. So if you are interested to learn more on this topic, or if you want to join our little endeavor, feel free to contact me or my colleague Fabian. Thank you very much.
Thank you so much for that, Lila. Appreciate the sharing with us some information on GEO's EO for Sendai monitoring community activity. Next, we have Mr. Sang-Ho Yoon of NASA's Jet Propulsion Laboratory, or JPL, to give us some background and information on GEO's global flood risk monitoring community activity.
Hello, everyone. Can you hear me okay?
Yes, we can.
Thank you. Thank you for having me. Thank you, Dave. And thank you, everyone, for joining. I'm a geophysicist and radar scientist at NASA Jet Propulsion Laboratory. And this work I'll be presenting was done with many people's contribution, as well as this ARIA project collaborative partnership with Earth Observatory Singapore and NASA's disasters program support. This work is also part of community effort called GFRM, Global Flood Risk Monitoring, with JPL, DART Flood Observatory, Dartmouth Flood Observatory, and Columbia University, Cloud to Street, and Remote Sensing Solutions. Now, I want you to imagine that you are in charge of disaster management office in Jakarta, Indonesia. And last night, you didn't sleep well because of the sound of thunder and pouring rain. The next morning, you wake up to hear that there's massive flash floods happening in your city because there was 40 centimeters of rainfall overnight. By the way, this actually happened on the New Year's Day this year. Then what do? You tell your team to check all the available satellite images to get an idea of what the flood extent is, right? A couple of hours later, 10:30 a.m. local time, your team brings the first optical satellite image acquired from MODIS sensor mounted on Terra satellites. And this is it. And 3 hours later, 1:30 p.m. local time, your team brings the second satellite image. and you feel frustrated, right? And then comes the synthetic aperture radar. If you're not familiar with SAR, synthetic aperture radar, it's basically high resolution imaging radar. So 4.5 hours later, Copernicus Sentinel-1 satellite acquired the SAR data. This is the SAR image amplitude. And notice that there's no clouds in this image. You can see the sea surface here, boats, ships here, and then this is the land part. In fact, the atmosphere is crystal clear to radar sensor 24/7. We compare this image with a number of SAR images acquired prior to the flooding. And this is one of the example. And you can see the difference between the two. And using this difference, we produce this flood proxy map proxy because we derive this product from remotely sensed data. And we rapidly produce and deliver this map to the AHA Center, ASEAN Coordinating Center for Humanitarian Assistance for Disaster Management. And they use this map to estimate the number of people affected by the floods. So we're producing these products based on our system called ARIA, Advanced Rapid Imaging and Analysis System. We're developing algorithm and system. This system will rapidly and automatically discover relevant SAR data and process to produce decision support products such as flood proxy map. And we also cloned our system, one developed in California at JPL in Pasadena, and another one in Singapore in a very safe place. Right at the equator, they don't have tropical cyclone. They do have monsoon rain, but they don't get flooded. But they're all affected by sea level rise. Back to flood mapping. Crash course in flood mapping. SAR image is a complex number array, and we are looking at the amplitude part of that. You can see this is pre-event scene, you saw this, and this is co-event scene. The difference, subtle difference, that's what we're after. And the rough surface, when the SAR transmit the radar signal, rough surface scatters energy in all directions. Some of them goes back to satellite, that's what we record. When the rough surface is covered with flooded water, it becomes like a mirror. So most of the energy is reflected away from the satellite. But when there's a house or vertical structure or trees, there's a double bounce effect in this side, in this urban area where we're focusing on. Double bounce actually increase the backscatter brightness increase. So that information we use before and after SAR image. We also utilize multiple SAR images called multi-temporal SAR analysis. And after normalizing the quantity that satellite observe, we use a Bayesian framework to calculate the probability of actually flooded given the observation, because it's difficult to directly calculate this. We use Bayesian theorem to calculate when we know which part is flooded, what is the observation, then we can calculate our desired probability of flooding based on our observation. We take one step further to engage deep learning, in this case, by using multiple images before the flooding event and let the machine learn about the dry scene, and then ask the machine to predict the next dry scene. Here, you can see its machine is improving the expected dry scene. And then on the epoch, on the time when it's flooded, there's no dry scene acquisition anymore, but we have this prediction, and we compare that prediction with the wet scene acquired by the SAR sensor, and then based on the difference between the prediction and the observation, we produce anomaly score map. here you can see this is the validation based on 30 centimeter optical area photos. And after 20 iteration, the machine is saying, oh, these blue areas and red areas are flooded. But in fact, some of the blue areas are permanent water. Some of the blue areas are a runway of an airport. Now, as the iteration goes on, machine learn more and more and knows that these are existing water, not newly flooded area. And you can see the machine is doing better by excluding these existing water body or airport runway, but it's still detecting the newly flooded area, open water, as well as urban area flooding here. So this effort is ongoing, and most recently, we produced this flood extent map of Central America. As Ricardo mentioned, just 10 days ago, we delivered this map of flood proxy map of Honduras and Nicaragua, and the World Food Program used our map for their situational awareness. Our efforts is ongoing. We're actively improving our methods and partnering with many others under GEO, and because we know quite noticeably floods are impacting more and more people, not just their night sleep, but their lives. Thank you for your attention, and please feel free to reach out if you have any questions.
Thank you, Sang-ho. Thank you very much for that update on the GEO Global Flood Risk Monitoring Community Activity and your ARIA efforts in this flood proxy maps. Our next presenter is Ms. Hélène de Boizen of CNES, the French Space Agency, here to talk about a CEOS working group disasters recently evolved activity called the Recovery Observatory Demonstrator.
Hello, so it is my pleasure to be here with you to present this working group disaster recovery observatory demonstrator activity. And so first, just as an introduction, I will present this slide about Hurricane Iota mid-November. And why is it important? It is because it is the recorded 30th named Atlantic hurricane in our season, already a Category 5 storm in November, so ever recorded. And just following Eta hurricane that happened a few weeks ago, so people were just recovering from Eta when Iota occurred. And so this is not unique to the Caribbean. In France, for example, a few weeks ago, there was what we call a medicane. So it's a hurricane occurring in Mediterranean Sea, where a conjunction of meteorological, very strong extreme phenomena caused serious deaths and economic loss. And the reinsurer Munich Re last year registered more than 800 natural disasters, and a number that have tripled from 30 years ago. And of course, climate change is one of the major factors causing such high rate of natural disasters. And so since the creation, so 20 years ago, of the International Charter Space and Major Disasters, satellites have grown to occupy a really critical place in assessing impact immediately after a disaster, helping in emergency response phase of the disaster. And there is not only the international charter, now there is Copernicus Emergency, Sentinel Asia, UNOSAT team, a lot of people working on this emergency response phase. But what about recovery? You see on this slide that there is several months, sometimes years of work after a major disaster. And so our opinion now and our motivation in the Recovery Observatory work project team in CEOS, Working Group Disaster, was that Earth observation has a role to play in the post-disaster phase. And so what is the recovery observatory concept? It is the fact that Earth observation at different scales, different so resolutions, with different wavelengths and so on, and frequencies, can help very efficiently providing data, information on the whole area, geographic areas that have been struck by a disaster, and if necessary, can make some zoom focused observation, maybe at higher frequency of specific areas like urban or environmental important areas. So we can really adapt Earth observation resources to monitor all the topics and all the parameters to be analyzed for the recovery steps. So in this recovery observatory project, we have worked with a number of partners, among the first of them being the International Recovery Community since 2016, to define a common vision of the recovery observatory. So it was the World Bank, GFDR, UNDP, and the European Union. And together with all those partners and together with space agencies from Working Group Disaster, we were able to set up a first pilot of recovery observatory on the Haiti post-Matthew hurricane, which started in December 2016. This Haiti Aero Observatory pilot successfully demonstrated that satellite data could be a valuable asset to support long-term recovery. And then it was decided to go on with a new step, that we call recovery. So this was, the recovery phases that were covered by the Aero pilot on Haiti. So we were able to cover the recovery planning and the recovery monitoring and evaluation phase during 4 years. And now, in the next step, we address what appears to be the most critical phase, where Earth observation is not used in an operational way and is really required by international stakeholders. It is the rapid assessment phase and the PDNA phase. So with our recovery observatory demonstrators, we will develop between 3 to 5 demonstrators in the next 5 years. We will answer the needs of recovery stakeholders in real case demonstrations. And so if we sum up what is a recovery observatory and its specificities, recovery observatory deals with the fact that the recovery phase requires very different satellite Earth observation needs than emergency response phase. In this recovery phase, a large number of enhanced and detailed value-adding products are required. So we really need not only satellite images, raw satellite images, but value-adding resources to extract information from those images. And in this approach, we work on a continuity of Earth observation information from the event itself during the emergency response phase to the national recovery plan, and if possible for the monitoring and evaluation of the recovery plan too, with what is very important, with strong involvement of local users, at least for, of course, a precise knowledge of the situation and of the needs, and if possible, trying to involve local EO derived product providers, if they exist, to be able to build, to create local capacity building and local capacities involvement. Of course, all this is done with closely engaged with international stakeholder communities. And what we have learned until now, sharing our experience with, so on IET pilot, but on UNOSAT and World Bank and other people working on this recovery topic, is that each recovery observatory can be has its specificity, and it can be a challenge to scale up. But we work on preparing a generic framework that will allow recovery community to trigger the Earth observation community to fill their needs when in situ data or local expertise it's not sufficient to provide all the necessary information. And so new partnership and of course new contributions. And if you are interested in being part of this project, you are welcome. And so please, you can contact us. And just as a conclusion, I would say that we, in this project, we first work to the priority 4 of Sendai priorities, Build Back Better, but to the governance priority 2, because we are closely in relation with local decision makers, national bodies, and so on, and to the understanding risk priority, because thanks to lessons learned on a post-disaster situation, we can help better preparing for future. Thank you for your attention.
Thank you so much, Hélène, for that update on the recovery aspects and efforts within our CEOS Working Group Disasters. Next and finally, we have Ms. Dahlia Kirschbaum of NASA to give some background and update to our group regarding the CEOS Working Group Disasters landslide pilot.
Thank you. And just checking you can see my slides?
Yes, we can.
Perfect. Well, thank you so much. So happy to round out this panel of speakers and really kind of talk big picture first and then focus in on some of our objectives. So as other speakers have commented, the value of Earth observations is both individually looking at a single process, but also being able to look across different satellite combinations, different products, and model activity to really get a sense of how the system is behaving with respect to natural hazards. And so what you see here is just an example of different satellite observations that NASA has, as well as models to really understand Earth as a system of systems. And so in the CEOS Disaster Working Group, and specifically in the landslide pilot, the goal of this is to harness as many observations on the ground, in the atmosphere, under the surface, to really understand landslide processes and use that to inform hazards at different scales. And so the way that this is approached is how we can look at these processes from using different questions, right? So we look at what type of activity is happening for landslides. Landslides are pervasive. They happen in nearly every country in the world. They kill thousands to tens of thousands of people per year, but the knowledge of where they're distributed and when they happen is very limited. We don't have global warning systems like we do for, or observation systems for hurricanes or seismic network. And so really understanding kind of where and when these happens is still a huge challenge in the landslide community. And also understanding how they happen, what triggers them. Is it an earthquake? Is it precipitation? When, of course, is always the important question, is how can we really understand this using satellite data and models to anticipate and mitigate against these events? And then after they occur, where are they? So using optical imagery, using synthetic aperture radar to really narrow in on what areas have been exposed. And so the goal of this landslide pilot and moving into this demonstrator concept is to look at the landslide life cycle, not just one specific aspect, but all over. And so I wanted to give, this is just some of the tools that we use in terms of data fusion between different techniques or different sensors, optical and synthetic aperture radar, and just the potential of citizens to map landslides or contribute information and sharing inventories across different countries, different academic groups. And so I wanted to just give one example of how we're doing this at a global scale. And so what you're seeing here is precipitation information from the Global Precipitation Measurement Mission, which is from NASA and the Japanese, JAXA. And so this is a multi-satellite product developed by NASA that looks at precipitation around the world. And so why are we looking at this if I'm talking about landslides? Well, rainfall is by far the largest trigger of landslides around the world. And so we know that extreme or prolonged rainfall in many of these high-risk areas with high topography, with fractured soils where humans have been developing onto steep slopes, those are prime areas or hotspots for landslide activity. So knowing this and being able to take advantage of dynamic information such as precipitation, we have combined that into a global model where we use precipitation with slope, changes in land cover, changes in geology or lithology, distance to road networks and faults to really understand where potential landslide activity may be occurring. And so this is a map that we've developed that highlights what we call nowcast frequency, or a model that can look at the potential activity of landslides for rainfall triggered landslides over time. And so we can see that this changes by month. The red indicates high areas of potential in that month, and the blue indicates, or gray is very, very low or no hazard. And when you overlay that with actual events, which is compiled from about 10 years, and the size of the dot indicates the number of fatalities in this area. And these are just individual reports. It's by no means a comprehensive view, but all of this data is public. The model is public. And so where do we go from here? So what we're looking forward to with this pilot is taking what we've learned about how we can apply synthetic aperture radar and optical data using machine learning concepts, how we can use models to model the processes physically and empirically, and then what can we do to really link that to decision making in this space. And so the demonstrator concept, which will be starting right at the beginning of this next year, is to look at 3 different applications that are quite diverse. The first is looking at how we can apply satellite data, both optical and SAR, along transportation and pipeline corridors. Now, deformation of slopes in key transportation areas or active landslides that block tracks or disturb pipelines is a major source of economic impacts for railway industries, private companies, and also could really result in pretty disastrous impacts. This is just an example of a landslide that blocked a railway and caused a catastrophic event in Kentucky. And so we're working with private companies as well as national networks to really see how we can develop best practices or effective practices for applying Earth observation data. The second application is looking at landslide risk financing. And this is something that's a quite new topic, and how Earth observation data can be used to better understand landslide risk financing. And so the World Bank Disaster Risk Financing and Insurance Program is actually funding a consortium to look at this with a pilot case over Morocco. And that work started in October. It will complete next year. And it really is this pilot phase to figure out how we can leverage EO data to advance this concept of landslide risk financing, working specifically with the financial institutions in Morocco. And then lastly, the goal is to kind of continue what we're learning globally and to develop networks and best practices for compiling and sharing landslide inventory data and information to really advance our ability to map right after an event using new techniques, new algorithms that are open source, as well as combine that information to advance our modeling knowledge. So this is a 3-year demonstrator, we hope, that will start in January, but we've built this legacy for the past 4 years through the CEOS Disaster Working Group. And we hope that working with other partners, other pilots, and activities, we can really advance these concepts to look at cascading hazards as well. So I will stop there.
Thank you so much, Dahlia. Very much appreciate that update on the CEOS Working Group Disasters Landslide pilot. Soon to shift to a demonstrator status, and with that increase in the maturity of your efforts, much appreciated. We got a little bit behind on our schedule, so sadly we won't have the time dedicated that we thought we did for a typical moderated panel discussion and as well as audience Q&A. But I have one burning question that I think I'll pose to our presenters in the time remaining that we have today. So multiple examples were touched on briefly in almost every one of your presentations. But in terms of partnerships between those that might also be Earth observation sector professionals, like many of the presenters, and the broader disaster risk reduction community to include private industries such as reinsurance agencies or national civil protection agencies, or simply the elected officials of towns or cities. What is one, or maybe your top success criteria that you have found that helps ensure the success of partnerships between these communities and really helps the uptake of new Earth observation technology and applications in ways that are sustainable and successful? And I'll open that up to any of our presenters that might want to comment on that or share perspective. Do we have any takers for my question here in our time remaining?
Dave, I'll start. I'm the one that uses less Earth observation because I'm new at the group. I'm a Sendai focal point. And what it really seems to work is these excellent examples that we're seeing. We found that with the politicians and also with the private sector, that it's really being able to visualize what you can gain, what type of information you can gain by using Earth observation. Just talking about it in too much technology usually doesn't help, but really good visualization. And I think one of the speakers who gave us a whole scenario about flooding and flash flooding really makes a huge difference.
Thank you for that, Janet. That's a very good perspective on that. Any final comments or responses to the question? And then I'm afraid that we're going to run out of time, but maybe one more response from any of our presenters.
Dave, if I may, it's Hélène de Boissezon.
Yes, Hélène, please.
Okay, yes. It is a very practical experience about our work in Haiti, where at the beginning of the project of the task, we were first in relation with ministries and central management in Port-au-Prince. But from the very beginning of the project, we were asked to go to very local areas and to be in relation with mayors and responsible for municipalities. And so we did 3 workshops and very practical work. And it was very interesting because the maps derived from Earth observation have been significantly enriched with suggestions from the mayors. Because for example, in Haiti, people are not used to looking at maps and so on. So they required us to add to the toponyms, to the names of the locations and so on, to add some pictures of very specific places very well known by the population, for example, marketplace, a church, or a specific building, so that people concretely in the city council can use the maps that are derived from Earth observation. And this, for example, this kind of enriched value-adding products, it was the first time that I saw and heard this kind of request. And in fact, it seemed to be very convenient for them. And so we have had this experience that was very rich.
Great, thank you for that example, Hélène. Very much appreciated. Sadly, we are out of time, and we must bring our session to a close here. But I do encourage all of our attendees The contact information for each one of our presenters is included, of course, in the Understanding Risk interactive agenda. So please track them down, reach out to them and ask them any particular questions, or of course, reach out to me as well, and come learn how you can get involved and support these and many more efforts across the GEO and CEOS communities in terms of Earth observations for disaster risk reduction. With that, I'll close the session. Thank you all, and have a wonderful day. Bye-bye.